Alright, today we are going to be identifying multiples of a positive integer, common multiples, and the least common multiple of a set of integers. So the main thing we're doing today are finding least common multiples and common multiples. For the vocabulary, a multiple of a number is the product of the number and any whole number. So that word integer up here, that simply means any whole number that you can come up with. So examples of that would be 0, 1, 2, 3, 4, 5, any whole number. If I had the number 25, it would be a whole number. So we know that a multiple is the product. So if it's multiplied against another number, it would be the multiple. A common multiple are multiples that are shared by two or more numbers, and that's when we would say that they are common. So common means the same. We'll look at some common multiples and examples in a moment. And the last thing we're going to be dealing with in this set of notes is the least common multiple. So if we have the least number that is a multiple of two or more numbers, it's the least common multiple. And you will see that abbreviated as LCM. It's just shortened, it means the same thing. Now let's take a look at some examples of LCM. Skip down to your notes where it says find the LCM of 4 and 7. That's going to be our example that we go through with our steps to solve. So for the steps to solve, our first step is to identify the multiples of 4. So basically how this is done is horizontally. We want to list our numbers from left to right. And we are going to simply count by 4s since we're finding the multiples of 4. So we have 4, 8, 12, 16, 20, 24, 28. So we're simply counting by 4s. This is the equivalent of 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. So we're just going in order, counting by whatever number they give you. So for the second step, we are going to now identify the multiples of 7, since that's the next number that we're comparing. So we know that the same thing applies here. We're going to list our numbers from left to right, always when you're working out multiples. So we want to count by 7s. We have 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. So we've listed out our multiples of both of these numbers, and we could keep going, but we simply want to find one number that they have in common. So we're going to keep counting by multiples until we find the smallest one they have together. So if they have this number together, we see that 4 and 7 both include the number 28, which means that our least common multiple of these two numbers, 4 and 7, equals 28. So let's try out another example. They give us the problem, find the LCM of 15 and 12. So if we are looking at the numbers 15 and 12, we're going to keep in mind that we are always going to list from left to right. So our first number is 15. We know that 15 times 1 is 15. 15 times 2 is 30. 15 times 3 is 45. 15 times 4 is 60. And 15 times 5 is 75. Let's stop there for now. If we do not have a common number, then we can keep going with the 15s. So our next number they want us to compare is 12. So we are going to put our 12 down here, and we're going to list the multiples. So we have 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. 12 times 5 is 60. So we realize that both 15 and 12 have a multiple of 60. Since they both have a 60, and that's the first number we see that they have in common, we know that our LCM equals 60. So this would be our final answer. Now, I want you to give the next one a try on your own before we check it together. It says to find the LCM of 5 and 45. Alright, so we know that we're finding the LCM of 5 and 45. And we know that we're always going to list them from left to right. So our first number is 5. We know that 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. We've got 25, 30, 35, 40, 45, 50. Let's stop there for now. So then we need to find the multiples of 45. In the same way, from left to right, we see that 45 times 1 would be 45. And we actually realize right away that we don't have to do much more work here because both of these sets of multiples have the number 45 in them. So that means that our LCM of 5 and 45 is going to equal 45. And 45 would be our final answer. Let's give some word problems a try. Alright, so in this problem, it says that Mr. Drake bought muffins and drinks for a breakfast meeting. The muffins were sold in packages of 8, and the drinks were sold in packages of 12. What is the smallest number of packages of each item that Mr. Drake could have bought and still have the same number of muffins and drinks? So we know that the first thing we need to do is find what the problem wants us to solve for. So we see that the question here is, what is the smallest number of packages of each item that Mr. Drake could have bought and still have the same number of muffins and drinks? So we need to find our keywords here. We realize that the muffins are sold in packages of 8, and that the drinks are sold in packages of 12. And they're wanting to know the smallest number of packages that Mr. Drake could have bought and still have the same number of muffins and drinks. So we know that by that word smallest that we are solving for the LCM. Now, the thing here, when we are putting things into groups, we do not want to mix up the muffins and the drinks. So we're going to go ahead and label muffins are sold in packages of 8. So muffins equal 8, and drinks equal packages of 12. And knowing that, we can go ahead and start finding our multiples. Remember, we always list those multiples from left to right. So we're going to start out with his drinks, which we know 8. The multiples of 8 are 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. We've got 32 next. 40. 48. Let's go ahead and stop there. We have our multiples of 12. We know that 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. But we can see already that we do have multiples that are common. Right here we have 24, and right here we have 24. Now, we know that in this problem they want to know how many packages. So since they want to know how many packages, we need to count up these packages before they get to 24. So right here, he has 1 package. Right here, he has 2 packages of muffins. And right here, he has 3 packages of muffins. So we know that he needs to buy 3 packages of muffins, and then we need to count how many packages of drinks. We know that 1 package of drinks has 12. We know that 2 packages has 24, which is what we need. So for the answer, our answer is not 24. The answer is 3 packs of muffins and 2 packages of drinks. So this would be the correct answer. 3 packages of muffins and 2 packages of drinks. Do not let the 24 confuse you. Now let's take a look at the second example that we have here. And the second question says that Chloe was adding fractions that had denominators of 8, 12, and 18. What number could she use as a common denominator? So we want to find what number could she use as the common denominator. And that her denominators are 8, 12, and 18. So if we want to find a number they have in common, we know we're looking for the LCM, and we're going to list our numbers from left to right. So the first number they give us is 8. We know that if we count by 8s, we're going to have 8, 16, 24, 32, 40, 48, 56, 64, and 72. For the number 12, we can do the same thing. We're going to count by 12. So we have 12, 24, 36, 48, 60, and 72. And for the number 18, we have 18, 36, 54, and 72. Which means that the number we see on all 3 of the sets of multiples is 72. So the denominator that's common that she will use on her adding of fractions is going to be the LCM equals 72. Now, I need you to go ahead and go to our Class Moodle site and write your summary in your journal for this set of notes.